The coefficient of determination is the proportion of the variation in y that is explained by the regression line, and it is computed as the following. R squared is equal to the explained variation divided by the total variation. Now the value of r squared is the proportion of the variation in y that is explained by the linear relationship between x and y. Example 2. Jackpot tickets data finding a coefficient of determination. If we use the 9 pairs of jackpot tickets data, we find that the linear correlation coefficient is r, which is equal to 0.947. Find the coefficient of determination. Also, find the percentage of the total variation in y tickets that can be explained by the linear correlation between jackpot amount and number of tickets sold. With r, which is equal to 0.947, the coefficient of determination is r squared, which is equal to 0.897. Let's go ahead and do that on our calculator. So we're going to take the value of 0.947 and then we're going to square that. And that gives us, rounding it to 3 decimal places, 0.897. Now that gives us that as a decimal. So if we wanted to convert that to a percentage, then what we would do is multiply this by 100%, which then gives us approximately 89.7, or rounding that to 90%. So now let's interpret this. Because r squared is the proportion of the total variation that can be explained, we conclude that 89.7% of the total variation in tickets sold can be explained by the amount of the jackpot, and therefore the other 10.3% cannot be explained by the jackpot. How do we get 10.3%? 100% minus 89.7%. The other 10.3% might be explained by some other factors and or random variation.